My name is Doug. I am a developer advocate with the Firebase team at Google. Thank you for joining me today, and if you're watching online, thank you for tuning in. So I do a lot of mobile development, and I work a lot with Firebase. I have the Firebase shirt. I have to work with Firebase. They pay me to. But I really enjoy working with it. Firebase has within it a bunch of products that help you build better apps, improve your app quality, and grow your app's user base. I spend a lot of my time on the products on the left-hand side, the build better apps. Now, most of these apps, or most of these products give you SDKs that let you work with backend services directly from your app. One of these products is special. It actually lets you build backend code, and that's called Cloud Functions. Cloud Functions is a Google product. It's a Google Cloud product. It's not a Firebase product, but Firebase adds tools and SDKs that make it really easy to work with if you're a mobile developer. So I'll use that today. Now, Cloud Functions is said to be serverless. Now, that's kind of a buzzword. What does that mean? Well, it turns out there are still servers. You can't get rid of the servers, and we're not fooling anyone. But what does serverless actually mean? If you're working with a serverless backend, that means there is no maintenance. So you don't have to set up any backend servers. You don't have to tune them. You don't have to configure them. All you do is write and deploy code. The backend servers scale up and down as needed. So if you deploy your code, the functions will run on demand. And if the demand is higher than the load or higher than the number of servers that are currently allocated, Cloud Functions will scale up new servers to meet that load, and it will scale them down as well. You only pay for what you use. So unlike traditional backends where you pay for a server to be up 24/7, with Cloud Functions, you only pay when a function is executed. So the billing is per invocation and for the duration of the time that the function runs. And Cloud Functions is event-driven. So the functions don't do anything until some event occurs in your project that triggers that, and I'll show you that in more detail. So when I say Cloud Functions is event-driven, what happens is one of the products in your Firebase project or Google Cloud project will generate events when something changes. So this is just a sample of some of the products that generate events. So Cloud Firestore is a real-time NoSQL database. If something changes in that database, you can trigger an event. These events will get delivered to Cloud Functions. So Cloud Functions basically is the central operating point for all of these events generated by your products, and then it will turn around and trigger the function in response. So you can write code that responds to these events in various Google and Firebase products. It also scales up and down with the load, like I said earlier. So if you have users who are invoking your functions in some way, Cloud Functions will allocate a server for that, and the function will run in response. And as you get more users, you will have more servers allocated, and this will continue to go as much as you need. For background functions, Cloud Functions will actually allocate up to 1,000 server instances running all concurrently as needed, which should be enough to handle most production load. And then as the users stop using your app, as load falls off, the servers automatically get deallocated. So all of this happens transparently. You don't see it, you don't manage it, it just happens. Here's a selection of event providers. So with Cloud Functions, you can write HTTP endpoints, so create a REST API, typical backend as a backend code that you call directly from your app. There are also a number of products that generate events. This is just a small sample, actually. There are more products here that generate events than are on this slide. The most interesting ones to me are Cloud Firestore, like I said, database changes. Also Firebase real-time database. When that changes, you can trigger events. Also on cloud storage, if you upload a file to your cloud storage bucket, you can run some code. And I'll actually show demos of all of these, cloud storage, Cloud Firestore, and real-time database. So why would you use Cloud Functions as opposed to writing logic directly in your app? Well, if you're building an iOS and an Android and a web app, you probably have some common functionality among all of them. You probably don't want to copy that in each app. You probably want to have that all in one place, one backend. You can share this logic across your app platforms. If you want your code to be fast and reliable, sometimes it makes sense to run it on a back end instead of on your front end. So if you have some heavy lifting in your app that you don't want to do in the app, or that you don't want the app to be online to execute, you can offload that to Cloud Functions and do it in the background. And another thing that comes up a lot in mobile development is you can't really trust the end user's device. So if you're building a web app, people can view source. If you're building an Android app, there's an APK. You can actually decompile that APK, reverse engineer all the code, look at all the configurations. Same thing with iOS apps. You really can't trust the user's device. So you probably have some sensitive or some secure code. You can move that into Cloud Functions as well. You don't have to have that in your app. So I've said a little bit about Cloud Functions, but what makes it most interesting is how easy it is to use and how powerful it is. So I'll take a moment and do a quick demo. So I've already created a Firebase project right here. Let's see. So I've already configured this as well. So I've enabled billing, so there's the pay-as-you-go plan has been enabled, and I've also enabled some APIs as well. But otherwise, this is a pretty new blank project. So the first thing I'll do is run the Firebase CLI. So I'll run Firebase init, and what Firebase init will do is let me work with some products. I will choose functions and hosting. I will use an existing project. And I will configure it for TypeScript. You can choose TypeScript or JavaScript. I'm a huge fan of TypeScript. I think TypeScript makes JavaScript a lot easier to use because it's typed, strongly typed at compile time, and it compiles down to JavaScript that you can deploy anywhere. I will use tslint, and I will not install dependencies now. I'm configuring hosting right now, so what hosting is doing is creating a directory for my web content. So I can see here there's a functions directory and my web public folder. So I'm going to go into functions. Actually, what I'm going to do is pull up VS Code first. In VS Code, let's make this a little bigger. So you can see here there's a source. It created an index.ts. That's my starting point for all of my code. And then there's also web content. I'll deal with the web content later. Let's see, what I'm going to do here first is, actually I'm going to look at package.json first. Package.json defines an entry point, so my index.js. It's going to use the Firebase admin SDK and the Firebase functions SDK. So what Firebase functions lets you do is define triggers to run and deploy. The Firebase admin SDK lets you access backend resources, and I'll use both of these. So the first thing I'm going to do is npm install. This will download and install all of the npm packages. So if you know Node and you know npm, it should be pretty easy to get started with Cloud Functions for Firebase. So I have my modules installed. The first thing I'm going to do is just comment out the hello world program. Actually, I'm going to get rid of the semicolons. I don't really like semicolons. OK. Now what this is going to do is, this is a standard HTTP trigger. So what it's going to do, actually before I explain it, I'm going to go ahead and deploy it. So I'm just going to run Firebase deploy. Only functions, and while that's deploying, I'll describe what this is doing. This is creating an HTTP trigger called hello world. It's using the functions SDK to define an HTTP trigger that when a request comes in, I get a request and a response object. So this callback basically gives me Express.js request and response. So if you're a Node programmer and you already know Express, these objects are just like the Express objects you already work with. And then what it's going to do is send a response, just a plain text response. Now when this is done deploying, this is always the worst part, waiting for a deploy to finish. What else is there to say about this while this is deploying? Actually, I'm going to make sure okay, I am connected to Wi-Fi. That's good. OK, we're done. So it gave me a URL. So you can see here that the URL is based off of the region of my project. So my project is hosted in the US. It's using the name of my project as part of the URL, and you can see the name of the function here is at the end. So what I'm going to do here is just curl on that, and you can see that the function ran. So pretty straightforward to get something running. Of course, this project or this function isn't very useful right now. I do want to create something actually useful. So I'm going to create a new function called fixUpMessages. Actually, before I write this, I'm going to go and show you the database that I'm working with. So this is just a very simple Cloud Firestore database. I have a collection called messages. So a collection is like a table in SQL. This has a number of documents, each with a unique ID. Documents are kind of like rows, and each document has some fields, and the fields are like columns. So right now, imagine this is a chat room, and I have messages accumulated in this collection, and this one has text which says hello from Firebase. So what I want to do is anytime a new message ends up in this chat room, what I want to do is change the text. So let's see. I'm going to write functions. I'm reaching into Firestore. I want to say when a document that matches this pattern, and the pattern is going to be messages and some wildcard ID. When a function is, or when a message is created, what I want to do is get the snapshot from that. Let's make this a little bit smaller. Okay, so what this is doing is whenever a new document shows up in this collection, what I want to do is change the text. So what I can do is take that snapshot, called data on it. This will give me a raw JavaScript object. And that raw JavaScript object will have a property called text for each message that has a text field. So what I'm going to do is pull that out. Actually, TypeScript is telling me this could be possibly undefined. Thank you, TypeScript, for pulling that out. But I know this will always be defined, so I will tell it to always dereference it. What I want to do here is actually, what I want to do is take that snapshot. It has a reference back to the document where it was created. I want to call update on it, so I want to change this document. I want to write the text field back. What I'm going to do here is call text dot. I like when TypeScript gives me hints about things. Okay, so I'm going to call replace. I'm going to take all of the instances of rock. Since this is a rock-themed conference, I'm going to replace everything with all capital rock because we want more rock, right? Actually, I'm going to go a little bit further. I'm going to put some emojis in here because we can never have enough emojis, right? We need the guitar and some hands, right? Okay, that's more like it. That's the rock I want to see. And one more thing, update returns a promise. So if you know JavaScript programming, promise indicates some asynchronous work. What we need to do is return this promise to Cloud Functions to tell it, wait for this thing to finish. If you don't wait for this thing to finish, Cloud Functions will actually clean up ahead of time. So now I have this function, and what I want to do is deploy it, but I don't want to deploy all the functions. I just want to deploy fixUpMessages. Now, while this is going, I will remind you that the way this works is I'm going to create a new document in here with an auto ID. I'm going to give it a text field, but I'm not going to add this yet. I have to wait for that deploy to finish. So by the way, if you haven't worked with Cloud Firestore yet, it's a cloud-hosted NoSQL database. The interesting thing about Cloud Firestore is it's real-time. So all of the Firebase SDKs for Android, iOS, and web let you listen to the contents of a document or the contents of a query, and if that document changes, you get a callback on the client. So what I'm about to show you is an illustration of how this real-time database works. You see, I'm dynamically changing the contents of this document, and so what I expect to see is the client should reflect that change almost immediately. The deploys are happening rather slowly today. That's unfortunate. Aha, now we're done. Okay, so let's go back to the console. I want to add a new let's see, you rock. So it's going to create a new document, and then what we should see here is aha, you rock. Right? It's so much better, isn't it? Let's add a new document. text, the castle outside is made of many rocks. Probably not the effect we wanted, but you can see it working just fine. All right, so let's go back to our function here. So we have a bunch of documents in our database. One of the common things you can do is create an API that fetches data from the database instead of querying it using one of the SDKs. So I'm going to create a simple HTTP API. We'll call it get messages. Functions, we'll create an HTTP function on request. I'm going to use async await. All right, and what I want to do here, actually, here I use the reference that Cloud Functions handed to me because it knew which document I was modifying. But if I want to reach into a document and I don't know where if Cloud Functions didn't give it to me, I have to use the admin SDK. So I want to do that from Firebase admin, and I have to initialize the SDK. So what I'm going to do here is say admin. I want to reach into Firestore in a collection called messages. I want to get all of the documents in that, and that's going to return me a snapshot. And I'm going to await it because get returns me a promise. It's hard to see here, a promise that contains a query snapshot. Now this snapshot has all the documents in it. I'm going to, let's see, the docs array on that contains the raw JavaScript objects for all the documents in there. And I'm just going to rewrite them all to the raw data from that. So this docs now contains an array of document data, and the document data are just raw JavaScript objects. And I'm going to say response send docs, and that's it. So what this is doing is this is telling Express, I want to send this JavaScript object. It will automatically convert it into JSON for me and send that to the client. So this should be all I need here. So I'm going to deploy my function called getMessages. And we'll have to wait for another deploy here, but that's OK. So the admin, while this is deploying, I'll talk a little bit more about the Firebase admin SDK. You can see here that I'm using it to access Firestore. It also has wrappers for dealing with cloud storage, for real-time database. If you're logging in your users with Firebase authentication, you can do things with those user accounts. The Firebase admin SDK makes it really easy to deal with Google and Firebase products from the back end. Now, from the front end, you don't use the admin SDK. You just use the platform-specific SDKs for Android, iOS, web, Unity, C++. There's Flutter SDKs as well. And this will finally finish. Please go faster. Aha. So we got a new URL for that. I'm going to curl on that, and it will give me a bunch of JSON, so you can see everything, all the documents we added in there. This is not very. I'm going to pipe it to something that pretty prints a little bit better. Aha! Now we can see all the documents in there. So just with a few lines of code, you can start to create very easy to use APIs for your backend products. So that's pretty good. So we've dealt with Firestore right now. I want to jump into a different product. I want to use, we'll do cloud storage next. So with cloud storage, I'm not going to write this function live because there's a lot of code here, but what I will do is copy it from a staging area. So what I want to do is use this. I want to copy all this in place. Now, what this function requires that billing is enabled because I'm going to use paid APIs, and that paid API is the Cloud Vision API. So what the Cloud Vision API will do, one of the things it will do, is look at a picture and tell you what's in it. It was called label annotation. And I need to install the Cloud Vision SDK first. So while that's installing, I don't need these lines. So what I'm going to do is require the Cloud Vision SDK. And what this function is doing is, it's called onUploadImage. Actually, I will describe this after I start deploying it. Well, that's going. Okay, so what this function is doing is it's using the functions SDK to say whenever a file is finalized in my storage bucket. The storage bucket is just a container for files. It's massively scalable object storage. And so when an object is finalized, I will get an object, a description of the metadata. Not the contents of the file, but just metadata describing it. The first thing I'm going to do is parse that into various parts. I'm going to make sure it lands in the images directory. So within the images folder, I'm looking for new files that changed here. The next thing I'm going to do is build a URL to cloud storage. So this GS URL is a Google Cloud Storage URL specific to cloud storage. It contains the name of the bucket and the name of the file. And what I'm going to do is use the Cloud Vision SDK to do label detection. So I will pass it the URL. It will download that file from the storage bucket and give you the results. The results is basically a bunch of strings describing what it found in that. Then it will reach into real-time database. So this is referring to the real-time database. It's going to create a reference to a node called images and the name of the file. So I'll show you what that looks like later. Then we'll update the node, which is assumed to already exist, and we'll just stick all of the labels into that node. So this thing is deployed. The other thing I need to do, since this is actually a website, so what I'm going to do here is copy a little bit of I'm going to have to recopy this recursively. Okay, so what this did is now I have something in my public folder. There's a new file called upload, and in there is a very simple website. All it has is a div to drop images and a place where I can log some data about that. The interesting part is in the JavaScript. So in the JavaScript, basically what I'm doing here, and this is just like 60 lines, the first thing I do is when something is dropped into that box, I'm going to upload directly to cloud storage. That's all this does, really. It uploads to cloud storage. Then I'm using real-time database. Whenever something changes in the database, what I want to do is just build some DOM with the labels that it detected. It's kind of hard to read here, but what we're going to do is load this. So, nope, I need to actually emulate. So what I need to do here is Firebase serve. So this is creating a local emulator using Firebase hosting. So Firebase hosting is just static website deployment. So I'm running a local emulator right now. And here I have my box where I can drop images. Now what I'm going to do here is I'm going to put this side by side with the console. And we're not using Firestore, we're using real-time database. So what we're going to do here is when something is uploaded, we're going to see data populate in real-time database. We're also going to see the results over here. So what I want to do is drag some images. So maybe one of the best games of all time, an image from that. You're free to disagree with me. All right, so we can see it uploaded a file, and the function ran and put the labels in the database. So you can see, excuse me, you can see that when I upload a file, the function is automatically running, invoking the image annotator, and writing that back into the database. So you can create some really interesting effects here. Here's a bunch of mobile devices. Kind of a mess, if you ask me. Oh, there's the results. Everybody likes ice cream. So you can see the database being populated and also it reflecting in real time in the website. And it didn't take very many lines of code to do this. Oh yeah, this is a rock-themed conference, so we have to do rock, right? All right, so you can see this is working pretty smoothly, I think. And again, it wasn't very many lines of code. I'll go back in here and just zoom out a bit. The total code for the JavaScript was 85 lines, not that much to work with. The total code for the function was, I don't know, 20 lines. So with a few lines of code, you can actually create some very dynamic and compelling mobile apps. You can do it for, like I said, Android, iOS, and web. Okay, so let's do another one. Actually, what I want to do here is integrate real-time database with a spreadsheet. So let's see. I have a staged function here again. So stage functions source. I'm going to copy scores to sheet. All right, so what this function is going to do, well, first I have to have the Google Sheets API enabled. The Google Sheets API lets me programmatically read and write Google Spreadsheets. And I need to install a bunch of modules as well. So I'm going to use Lodash for some JavaScript functions and the TypeScript bindings for that, and Google APIs, which gives me the API to read and write sheets. So I already have this imported. I need to reload this. Aha, so we're going to use Google APIs and the Google API sheets. So I'm going to go ahead and deploy this first and then explain it while it's deploying. So what this function does is, actually this isn't going to work because I have some configuration I need to do first. So this function needs to know the ID of the spreadsheet that we're working with. I already have that loaded up. The spreadsheet is over here. The ID for the spreadsheet is in the URL. I can just kind of copy that out. And I'm not going to use the require file. I'm actually just going to so it needs the ID. It also needs a service account. A service account is a Google Cloud concept. Basically, it's a privileged account that lets you read and write things using credentials that you specify. So I do need to download that file. I can get that in the Firebase console. What I'm going to do is go to users and permissions, find service accounts. So for the Firebase admin SDK, I can generate a new private key. What this will do is download a new file. I'm going to copy that file into my project. So I'm going to copy downloads. I'm going to copy this into the functions folder. I'm going to copy it using service account.json. So if we go back into the code, that's what's being required here. So we're going to pull this into memory. It looks like this. So this is all of the credentials. The one thing that I'm really interested in is actually this email address. This isn't a real live email address. This is just kind of a unique ID that identifies this service account. I do need that because what I need to do is, actually now I can deploy it. And then what I will do is go into the spreadsheet and share this. And I'm going to put in the email address. So I'm effectively sharing this spreadsheet with the service account. I'm going to give it edit access so it can deal with the spreadsheet. Now this is actually going to try to send an email to that account, but of course that account's not a real person. But the point is we've given access to that service account to make changes to this spreadsheet. I'm going to go back into real-time database so we can see it active in real time. This is taking a good long time to load. Let's go back to the code. Still deploying over here as well. I have feedback for the conference organizers. We need faster Wi-Fi. Okay, so here's all the images we put in there before. Actually, I'm just going to go ahead and get rid of those. Still deploying. Okay, let's talk about what this function does. What it's going to do is create a JOT that describes the service account, and it's going to request access to read and write spreadsheets. We have a function that says, using the Cloud Functions SDK, reaching into real-time database. Anytime any data is written to this node, so underscores, I'm going to get a change object, which describes the before and after state of the database that changed. So I'm going to pull that data out of there. I'm going to use Lodash to sort it and do a little bit of manipulation. Then I'm going to make sure that my JOT is authenticated. I'm going to use the Spreadsheets API to update using that account, using the spreadsheet ID that I gave it. I'm going to affect a range of cells, so from A2 to B7, you know how spreadsheets work. We're going to give it raw data, and the data is going to be my sorted scores. So what this is going to do is effectively respond to changes in real-time database and copy that into a spreadsheet. So assuming everything is loaded up here, the node was called scores. Let's see, I'm going to give myself a score of 10. How about that? Update. I'm expecting to see things in here, but I'm not seeing them in here, so now I'm going to have to debug this. Yeah? What did I mess up? Okay, I'm going to have to go into the functions console and make sure this function actually triggered. Error, requested entity was not found. Oh, I have never seen this error before. What is going on here? Let me make sure the spreadsheet ID is correct. Oh, I bet I missed. Yeah, that spreadsheet, aha. Didn't get this part. Double click failed me. Okay, well now I have to deploy the function again. That's not the worst thing that can happen. That error message, I will say, was very unhelpful. That's why it's a problem with doing live demos, right? Anything can go wrong. There's a whole slew of things that can go wrong, but live debugging is always fun as well. I don't know, maybe you found it helpful to see that. Okay, we have to go back to database. And pretend this never happened. Oh, where are we at? Still deploying. The good news is we're going to have plenty of time for questions after this is done, though. So please be thinking of things you want to ask. And don't ask me, how can I speed up the deployment? Because I don't know how. It's not oh, there we go. Okay, let's try this again. I've gone from 10 to 11 since we last spoke. So. Do it. Do I have to debug this thing again? Oh, boy. Oh, it's the same error. Oh, that's unfortunate. Yeah, I don't know. Well, you know what? I will tell you what would have happened. So if I had made the change, let's see. Now, what it would have done was detected that something changed in here, and it would have sorted and written it to the database like that. And if I were to add another node here, DevFest is much better off than me. Oh, now it changed. Oh, I bet. So, okay, I see what happened here. The deployment, when it finished, it wasn't fully active. So I needed to wait a little bit. So when the deploy finishes, there's still a little bit of lag time before it actually takes effect. Nantes is doing much better than both of us. Give me a little credit here. Yeah. No, I'm really liking this DevFest, though, so I'm going to give it even more credit. So you can see, what we've done here is made it really easy to glue two products together. So on the one hand, I'm just writing to the database, and on the other hand, that database data is being reflected in a Google Sheet in real time. The interesting thing here is that with the Cloud Function, I've basically eliminated the need to create a UI for my leaderboard. The UI is the Google Sheet, so I don't have to write any front-end code for this. So I don't know, maybe for some applications it actually doesn't make sense to write a client. Maybe it just makes sense to use a sheet, share that with everyone, so you could say anyone can view, and then use that as your UI. Now, for polished products, you probably want to have your own, a public, fancy UI. But for internal dashboards, maybe it makes sense to just use Google Sheets. So that's what we've done here with Cloud Functions. And again, there wasn't much code here. If we look at this, from 55 to 95, so 40 lines of code is all it took. Now, it did take me some time to figure out how to do the authentication and how to work with the spreadsheet. But that knowledge, once you learn it and have it in code, it's pretty easy to make changes and just do whatever you want as you need to. So that's all the demo I have. I will say a little bit about the architecture for that image identifier. So what happened here, if you remember the one where I uploaded the image into the web page and the web page wrote it to cloud storage, here's what happened. I uploaded the image. It wrote metadata to real-time database. It uploaded the image to cloud storage. The upload triggered Cloud Functions, which used the Cloud Vision API. It read the file or the image directly from cloud storage, and then I wrote the labels back to the database. This pattern is very common for the kind of functions I write. So I'd like to make little diagrams of these things. I have another talk, actually, where I make a, actually, I did this at DevFest London, but that doesn't apply here. So there's another one where I wrote a universal translator that uploads audio to cloud storage, triggers a Cloud Function, pulls the speech out of that using Cloud Speech API, translates it to a bunch of different languages, and writes those translations to Cloud Firestore, where those get distributed to a web app. So this is actually a really fun demo, and I have code for that as well. So we've seen now there are a lot of good reasons to use Cloud Functions, but it's not for every application. You might have noticed that there was a delay the first time that Cloud Firestore trigger ran. It was about 4 seconds or so. That's called a cold start time. It would normally be instantaneous, but there is a cost to firing up a new server instance, running Node in it, and invoking your code. That's cold start time, and that can be intolerable for some apps. So if you can't tolerate cold starts, and some apps just can't, you do have to run your own servers 24/7. So you'd have to consider something like maybe Google App Engine or running your own server farm. Cloud Functions are not good for very heavyweight work. There is a 9-minute configurable limit to functions. If you can't get your work done in 9 minutes, the work will be canceled. If you can't do it with under 2 gigabytes of memory, also Cloud Functions is not the best choice. In that case, you might have to delegate your work to App Engine or Compute Engine, where you have more flexibility. If you need to keep a socket open or do streaming, Cloud Functions doesn't support that as well. Cloud Functions is just HTTP request response, so you can't do WebSockets, you can't do like raw socket communication. That just doesn't work with Cloud Functions. There's no easy alternative for this. I believe actually Google GKE, Google Kubernetes will do sockets, but with Cloud Functions there's really no way to do that. Now, if you want to learn more about Firebase and more about Cloud Functions, there's a bunch of resources here. The documentation is quite good. Those video tutorials, if you did not like watching me and listening to me today, don't go view the video tutorials, because it's all just me talking about Cloud Functions. But some people find it very helpful. There's a tremendous amount of sample code, about 40 or 50 sample functions, if you want to see what it can do. There's a code lab where you can get started on your own. My GitHub has some interesting things in it. And also that universal translator that I told you about, that's in a GitHub repo with full instructions on how to get that set up and running. That's all I have. Thank you.